This is video 2 in the Further Statistics video series. In this video, we'll be looking at expected probabilities in more detail. We'll be going through some more complex examples, carrying on from video 1. So I wanted to start off with dissecting what a discrete random variable is, because the expected probabilities we've been calculating are for discrete random variables. So a discrete variable is a variable that can only take certain values, for example, integer values, and a random variable is a variable whose value depends on a random event. So an example is like rolling a dice. And for these problems, there's generally two things that we need to keep in mind. And that is the formula for the expected value, which is the sum of x times the probability of x occurring, also the mean, and that the sum of the probabilities is equal to 1. Usually, if we get a problem where we need simultaneous equations and there's two unknowns, these are the two kind of pivotal and essential rules. So definitely keep this in mind when going through the questions. The questions I've pulled are from the Pearson Further Statistics textbook, and so I do recommend going through all the examples on that just to get your head around kind of the procedure, because it does get quite formulaic after you do a few examples. So the first example we will do, a discrete random variable x has the following probability distribution. Okay, so write down the probability distribution for x squared. We haven't yet done this, we only yet done ones with e to the x. So in this problem, we just need to convert this value into x squared. So if x is 1, then 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, and 4 squared is equal to 16. And we just simply put these in here. 4, 9, 16. Okay. And so for part B, find e to the x squared. So if we remember this formula, now we simply just square all the x terms, and we simply do the same thing that we would do to calculate e to the x. However, this time we just use the x squared values. So x squared times the probability, add x squared times the probability, add x squared times the probability, add x squared times the probability, and this should get us the value of, if you just plug this into your calculator, you should get 4.8. Now for our second example, this is a lot more tricky and quite a big step up. Okay, so the discrete random variable x has a probability function as presented. Given that e to the x equals 1.2, find the value of a and find the value of b. So in this problem, we know that because we need to find the value of a and the value of b, we will need two simultaneous equations. So we will need to remember our two rules, which we have stated up here. Okay, so firstly, we want to lay out our probabilities. Okay, so if p x equals x is equal to a 1 minus x, for the values of x is equal to -2, -1 and 0, it may first help to substitute the values of x into this equation. So a 1 minus -2, this is for x equal to -2, is equal to 3a. For x is equal to -1, we get a 1 minus -1, which is equal to 2a, and for x is equal to 0, we get a 1 minus 0, which is just equal to a. And as we can see, that for x equals 5, the probability is just b. So we have, for x equals -2, the probability is 3a. For x is equal to -1, the probability is 2a. For x equals 0, the probability is a. And for x equals to 5, the probability is b. Okay, so using this information, we can apply our first rule, which is that the sum of x times the probability of x is equal to the expected value. Okay, so in this case, the expected value e to the x is equal to 1.2. And so if we just use our formula to calculate e to the x and equal that to 1.2. So x times the probability of x, add x times the probability of x, add x times the probability of x, add x times the probability of x is equal to 1.2. And as we can see, this will be minus 8a add 5b is equal to 1.2. Okay, now we can apply our second rule, which is that the sum of the probabilities should equal 1. So for the rule 2, we have 3a add 2a add a add b. And so this would be 6a add b is equal to 1. So this is equation 2 and this is equation 1. So now if we solve these simultaneously, 6a add b is equal to 1. Okay, so to solve this equation simultaneously, minus 8a add 5b equals 1.2. So times this bottom equation all by 5 to get the values of the b the same, so we can cancel them. So 30a add 5b is equal to 5. If we minus this, we get minus 38a equals minus 3.8. So then we get a is equal to minus 3.8 over minus 38 equals 0.1. And then we can plug this value of 0.1 back into this equation. So 6 times 0.1 add b is equal to 1. So 0.6 add b is equal to is equal to 1. So b is equal to 0.4. So our overall values, a is equal to 0.1 and b is equal to 0.4. And we work this out using these two rules above, which again, in a discrete random variable problem, just remember these two rules and you'll be fine. So in the next video, we'll be going through the variance of discrete random variables.